Hi everyone, today we will be solving the question of parenthesis checker, or you can say balancing parenthesis on Geeks for Geeks. So this is an easy question and you can solve this in O of n time complexity and also space complexity using stack implementation. So how we want to solve this is that, so let us see the questions what they have given. So initially they have given the string x and the string is like this. This is the expression they have given, and what we need to do is that we will check whether the parentheses which they have given are balanced or not. Suppose if they have given parentheses like this one and this is the string x, these two are balanced, so it is true balanced. Suppose they have given like this is also balanced, so it is balanced. We will return just balanced. Suppose I have given example like this one. As you can see, this is not balanced parenthesis because these two are matching, but these two are not. These two are also matching, but this one is empty and there is no entry symbol for this in front of the stack, or you can say the string. So this is not balanced. The brute force method for this is that whenever an input comes, we will just store it, and for the next input, suppose if next input is like this, we will check whether the matching parenthesis for this one exists in our stored array or something like that. If it does not exist, then we will return false. So what the problem with brute force is that we need to search the entire stored solutions, and the time complexity for each one, for each of the string will be O of n, so it will be O of n square. So now if we want to solve this question using stack implementation is, let me just show. So now if we want to solve this question using stack, means that initially we will take a stack, empty stack. I'm solving in Python, so anything, it doesn't matter. Suppose if the string is like this, they have given the test case of this one. So what we will do is that initially whenever the first symbol comes, we will just keep it in the stack, no need of checking. So whenever the next symbol comes, or we can say for each and every symbol, every I, what we need to do is that we will check whether this symbol is equivalent to stack top. So before doing this, what we will do is that how we will check normally, we will keep that this symbol is equivalent to this symbol is equivalent to this, and this symbol is equivalent to this. So whenever these three conditions are matching, then we will say the parentheses are matching. So we need to check these three conditions at each step. So what we will do is that suppose if this symbol comes, we will insert. This symbol comes, we will insert, because these are starting symbols and there is no need to check for the stack top. So whenever this first symbol comes, whenever this symbol comes, what we will do is that we will check the current input, which is I equal to this one, with stack top. Stack top is nothing but top of the stack, element on the top of the stack, which is nothing but this symbol. So these, I'm sorry, stack top is nothing but left closing bracket. So whenever this symbol and this symbol, these two are equivalent, we will keep on if condition that these two are equivalent. If these two are equivalent, what we will do is that we will just pop the top of the stack. Then what will happen is stack will be updated as this one, and this symbol is gone. This symbol is just gone. Now coming to the next input, which is this one, the curved right parenthesis. So whenever this one comes, what we will do, same step we will apply, that we will check if the current input symbol I equal to this one is equivalent to the stack top. Stack top is now updated one, which is nothing but this one, this one. So what we will do, these two are equivalent. So what we will do, we will just pop the top of the stack. Now the stack top is this one. Now third step, the input at each iteration, the input after matching will move to next one. So now the input, current input is uh, closing right parenthesis. We will check whether this is equivalent to stack top, this one. Equivalent in the sense these two are one pair. So what we will do is that we will just pop the top of the stack. So this one is also popped. So the final stack will be empty. If the stack is empty, then we will simply, length of the stack is just 0. So we will just say that the parentheses are matching, and we will return balanced. If the top of the stack does not match, that means there is something in the element which is not matching. So what we will do is that we will return not balanced. So let us see one example for that one also. Suppose if the input string is like this one, these two are matching. Suppose this one is not matching and this one, this is our input thing. So what we will do is that initially we will just push this one, and for next symbol we will check whether this one is equivalent to stack top. No, these are not equivalent, so what we will do is that we will just push this one. So this is pushed. Now again at step 3, now I will move to this one. Now here we will check whether this one is equivalent to stack top. Yes, these two are equivalent, so what we will do is that we will pop this one. So the updated stack will be just this one. Next iteration, again this one came, we will check whether this one is equivalent to this one. These two are equal but not equivalent. We will pop only when this one and right parenthesis opposite symbols come, then only we will pop the stack. If they are not opposite symbols, then no need of doing anything, we will just push into the top of this stack. So this is also not matching, this one and this one are also not matching, so we will just push into the top of this stack. This is our updated one, and again I will iterate to next one. Now the next input symbol is this one, and the stack top is this one. These two are opposite, so these are equivalent, so what we will do is that we will pop this one. So updated stack will be like this. Now what happened is that we ran out of the input string I equal to length of the string, and the input is completed. Now but the stack is still not empty. Some element is there inside the stack. So simply what we will do is that we will return stack not empty, so not balanced. Let me tell the time complexity of this one. As we are using the stack, the space complexity is often for stack, and the time complexity is for at each iteration we are just taking the stack top and also the input length strings element. So we are moving from I equal to 0 to I equal to n, and we are checking uh, each element with the stack top. So time complexity is also often, and space complexity is also often. Let us see the coding part. Hi everyone, so let us solve this question in code. So what we need to do is that they have given the string x, which is nothing but this expression, and we need to check in using the stack. So what we will do is that we will iterate the stack, and we will check whether the current input symbol, if three conditions we need to check, whether the current input symbol is this one, and the stack top, which is nothing but stack top is opposite of this, which is nothing but this one. This is one pair, and I will just use this pair for other kind of symbols, like whether the stack top is this one and input is this one, and whether the stack top is parenthesis and current input symbol is this one. So whenever these three conditions satisfy, then what we will do is that we will just pop the stack top. If not, then what we will do is that we will just insert the current input symbol into the stack. After completion of this, we will check whether if uh, stack is empty, then we will return true, else we will return false, that it is not. So let us quickly check whether this code works or not. um okay. Okay, so the problem is, okay, any of these conditions can satisfy. Yep. And this equal to symbol, this is not assignment, that's why. Yes. Yes. Okay, so let me just quickly submit it. Next index out of range. Okay, so before accessing the stack top, we need to check whether um, an element exists or not. If it does not exist and we are trying to access, then it will give out of index error. So we will check whether if the stack top is not empty and these conditions satisfy. If it is, then we will let us submit it. Yes. So thank you for watching. Have a nice day.